Have you ever stopped to wonder how your phone just knows the fastest way home during rush hour? Or how we can predict how much food will grow from space? Well, the answer is hiding in plain sight. It's a set of powerful, pretty much invisible technologies that are constantly mapping and making sense of our planet. So let's pull back the curtain on the systems that are basically building a digital twin of our world.
All right, here's our game plan. We're going to start with the basics. What even is geospatial data? Then we'll look at the incredible tech that collects it. After that, we'll dive into how AI is completely changing the game, see how it's affecting our daily lives, and finally, we'll peek into the future of all this location tech.
So first up, what is geospatial data? Because trust me, it's so much more than just the simple maps we look at on our phones. This is the deep, complex information working behind the scenes. And at the very heart of all this is something called a Geographic Information System, or GIS. Now, don't think of it as just a map maker. It's a whole system. It's kind of like a super smart database that connects any piece of information you can think of, like population stats or property lines or even elevation, to a specific spot on planet Earth. It creates these powerful digital layers of understanding. Now, a GIS basically sees the world in two different ways. On the left here, you've got vector data. The best way to think about this is like you're drawing with a pen. You're using really precise points, lines, and shapes to represent specific, distinct things like a single road or a building. But on the right, you have raster data. This is much more like a digital photograph. It uses a grid of pixels to paint a continuous picture of something, like temperature across a region or a satellite image. So the key takeaway is this: vector defines things, while raster paints the whole picture. Okay, so we know what the data looks like, but how do we actually get it? This is where it gets really cool. We're going to look at the incredible technologies that gather all this information, from right here on the ground to way up in the air, and even out in deep space. You know, a massive chunk of our global understanding comes from our eyes in the sky, satellites. They are just constantly circling our planet day in and day out, capturing this nonstop stream of images that literally tells the story of our changing world. But here's the thing, not all satellites see in the same way. On the left, passive sensors are basically like a regular camera. They need a light source, like the sun, to bounce off something and capture an image. That means they're kind of useless if it's cloudy or dark. But active sensors on the right, well, they have a superpower. They make their own light. They send out their own pulses of energy and then record what bounces back. This lets them see right through clouds, smoke, and even total darkness. And a perfect example of an active sensor is synthetic aperture radar, or SAR. Because it can see through all the stuff that blinds normal satellites, SAR is an absolute game changer. It's essential for keeping an eye on places that are always cloudy, like the tropics, and it's absolutely critical for getting information during a disaster when every single second counts. Of course, it's not just satellites. We've got a whole toolbox of tech. LiDAR uses lasers to map the ground in stunning 3D detail. The GPS that's in all of our pockets gives us the precise ground-level locations that anchor all this other data. And good old-fashioned aerial photography from planes gives us yet another layer of incredibly valuable, high-resolution imagery. And this brings us to a really critical moment. We have all this amazing technology collecting just unbelievable amounts of data every single day. So the challenge isn't really getting the data anymore, it's making sense of it all. And that is where AI comes in. I mean, let's just ask the big question here. With this constant flood of images, this absolute fire hose of information coming from space, how could we possibly analyze it all? There's no way a human could look at every single pixel. The scale is it's too big.
The answer starts with a concept called a satellite image time series, or SITS. Instead of just looking at one snapshot in time, we look at a whole sequence of pictures of the same place over time. Honestly, the easiest way to think about it is like a time-lapse video of the Earth from space. It reveals all these patterns of change, like watching a forest grow, a city expand, or crops moving through a season.
So this visual here shows that time series data as a stack of images. And AI doesn't just see one picture, it analyzes the entire history of that location through that stack. And by looking at all those patterns over time, it can learn to make incredibly sophisticated predictions, whether it's for a single pixel, an entire farm, or a whole region.
And the key that unlocks all of this power is deep learning. These are really advanced AI models called neural networks, and they're designed to find incredibly subtle and complex patterns. They can see relationships across space, through time, and in different wavelengths of light, patterns that are completely, totally invisible to you or me.
Now, don't worry about understanding every single box and arrow on this diagram. Just appreciate this. A complex model like this is basically a pattern-finding machine. It learns the rules of how the world works and how it changes just by looking at the data. And that lets it do amazing things, like automatically telling the difference between corn and soybeans from space, or detecting illegal deforestation the moment it happens.
Okay, so this all sounds pretty futuristic, right? But what does it actually mean for us right now? Let's take a look at the real-world impact and see how this combination of GIS, remote sensing, and AI is already shaping our lives every day. The applications are, well, they're everywhere. In agriculture, it helps us forecast the global food supply. In disaster management, it helps us spot wildfires before they get out of control and was absolutely vital for mapping damage after the 2011 Japan tsunami. Economists are even using pictures of city lights at night from space to estimate economic activity. And of course, it's a cornerstone of environmental science, letting us track deforestation and the health of our planet.
And this whole field is moving at an unbelievable speed. So, for our final section, let's take a look ahead. Let's see what trends are pushing the boundaries of how we see and how we interact with our world. One of the biggest, most exciting trends is the move toward open data. For a really long time, this kind of high-quality data was locked up and super expensive. But now, you have projects like OpenStreetMap and the Overture Maps Foundation, which are backed by some of the biggest names in tech, creating world-class datasets that are free for everyone. This empowers anybody, anywhere in the world, to build new tools and solve their own local problems.
And check this out. This is a really fascinating one. Geospatial data meets blockchain. By using blockchain technology, we can create location-based records that are secure and basically impossible to tamper with. Just imagine fraud-proof land titles or a supply chain where you can track an item's exact journey from a farm to a store with total, complete certainty. It brings a whole new level of trust to location data.
So, at the end of the day, we are building a digital twin of our world, a living, breathing map that sees and understands change in almost real time. And that leaves us with one final thought. As our ability to map and model our world becomes more and more powerful, more and more detailed, the real question isn't about the technology anymore. It's about us. How are we going to choose to use this incredible power to shape our collective future?